Okay, this is the last one, and the reason I did this is because R90, that actually means rotation of 90, not reflection. I was going to come in here and start teaching for me. Okay, so how do I do that? That's tough. So not reflection, rotation. Let's move up here and let's look at where we had reflection, capital R reflection, but it's going to be given away when there's an angle measure. So I know this is where this book, I've never seen this before, but capital R means reflect, but you can see that in the way the question's worded. Lowercase r means rotation because there's going to be a agreement. I don't think it's really a big deal there, but this is a big deal. It's a little weird here. I'm going to take this one point at a time and pretend that this is like a segment from here to here, because you are rotating about the origin when you do these rotations, 90, 180, 270, 360. And just understand that this point is 2, 1. And then I did intimate about this when we say positive 90 degrees, that's a counterclockwise move. That was in the quizzes that we talked about. But how the heck do I take this C and rotate it 90 degrees and know where it ends up? It's going to come out of nowhere, but I just know this is the fact. Watch what happens, okay? -1, 2, -1, 2, that point right there. When I draw this right here, and I got a protractor, that would be 90 degrees right there. So I'm going to put this off to the side. Rotating 90 degrees, and the coordinate is x, y. Look at what it ended up becoming. -1, 2. So that is a switch of x and y, and the opposite of that. Okay, so that is weird, and that's what we actually have in this. And remember, in our composition of functions, we do this first. So I have point C, I don't care where I start with. To rotate that 90 degrees, this is what the new coordinate becomes. Coming out of left field. I got you, man. I know. Right? But just kind of lock it in. This is the kind of question that separates the men from the boys, women from the girls, I like to say. If you can remember this. All right, so then let's take these other coordinates and give it a practice here and see if this does end up looking like it's rotated 90 degrees. So B is 3, 5, right? I should have kept those from the previous. According to silly little Mr. Samuelus, point B is 3, 5. These switch, and I have the opposite of it. Well, let's look at that graphically and make sure -5, -5, 1, 2, 3. If I were to draw those as a segment back to the origin, then back to B, oh, that's a bad mark. Doesn't that look like a 90-degree angle? Doesn't that look like that this has been rotated 90 degrees about the origin? So the answer is yes, this is how it happens. I'm going to go back, I'm going to finish this question and talk about rotating 180 and then 270. And of course 360, come on everybody, right back where you started. So that's when they always say, he just did a 360. When they say, hey, he just did a 180, he completely turned, or she, on whatever the idea is that we're talking about. -6, 4. Okay, so that's -6, 4. So switch those. Has nothing to do with inverses, switching x and y and all that. Nothing. It's just this is what happens. Because watch where I put -4. Oh boy, 3, 4, 5, 6. Well, you probably have to take my word on this one. Boom, boom. 90-degree angle. It's rotated. Okay, it works. Just lock it in. Okay, and then I think the next part's pretty easy. Then you do D2, where the dilation by 2. Just multiply everything by 2. -2, 4, that's simple. -10, 6, that's simple to draw on this. Coordinate plane is not big enough. So I can imagine of the last 2 examples, or maybe 3, where what are the vertices of the new picture? You just do the math. You don't actually have to draw it. That's the idea behind this. Okay, so unfortunately, I'm going to talk about rotating some more. This question's done. But what about 180? Okay, rotating 180. Watch what happens when I want to rotate this 180. Well, to rotate this 180 is exactly across on the other side of the origin. I'm trying to make this happen, kind of missed. Wouldn't you agree that that's a straight line? By the way, all lines are straight. Don't ever say that again. It's like a redundancy. Okay, but don't you agree that that forms a line when I connect these 2 points? So to rotate 180, you actually just take the opposite of the x and the opposite of the y. I mean, look at this, 2 comma 1. This is now -2 comma -1. So that is a rotation of 180 degrees. Let's take that letter B. What was this, 3 comma 5? Look at -3, 1, 2, 3 comma -5. Oh, great. So when I go and take this, that is taking this point and rotating it 180 degrees. So you go from quadrant 1 to quadrant 3. This angle measure, if this is the vertex, is 180 degrees. So that is why this is a 180 degree rotation. And then to go to 70, they ever ask you that? Well, obviously we're going to be in quadrant 4. I think 2, 1 is better to take. Let's take 2, 1 and rotate it to the opposite chord. So you'd have 2, nope, sorry, that's wrong. 1. So it's actually this, plus y negative x. So it's kind of related to 90, but you know, you got different signs on there. So let's take this 2, 1. So 2, 1 becomes 1, 2, but I have the opposite on 2. 1 comma -2. Now, if I look at this, let's look at it this way. You know that 270 is 90 short of 360. So that's a 90. So guess what? This is 270 as a move there. So this stuff off to the side, again, it's nice to know this is a memorization factor, how to do rotations, what do you do with the coordinates involved in order to make that happen. Go ahead and lock that in and put that in your notes. This video is a little longer just because it's taken some time in those rotations. We'll probably have discussions further live with those before we move on to other chapters or sections. All right, thanks for listening.